Paul, you're an energy efficiency expert. We've worked with you in the past, and we've asked you back because we need you to help us think about how we monitor the electrical use in the house. How do we do that?
Well, you can start by looking outside your house at the electrical meter.
Okay.
And what I've got here is a 60-watt incandescent bulb hooked up to that meter. And the trick is to watch the spinning dial.
If that is spinning, we are drawing electricity, and it's actually spinning relatively fast.
Right. Now I've got a 15-watt compact fluorescent bulb on the other side.
Look at that slow down. And so I guess that's the trick. We want to get that wheel to spin as slowly as possible with the same output.
Exactly. So in this case, technology has come to our rescue, and we can use about a quarter of the power to give us the same amount of light.
All right, so how do we actually monitor the usage of individual appliances throughout the house?
Well, moving inside the house, we can use any one of these electrical meters, and these are individual appliance meters. They each are, they work about the same. They have slightly different features, but essentially you plug your appliance into the meter, and you plug the meter into the wall, and they will tell you how much power or dollars that appliance is using.
Plug my refrigerator into this device, and it'll tell me how much power and what that refrigerator is costing me to run?
Exactly.
Okay, so that's really good information. I guess the downside is you either have to have one of these for every appliance you want to measure in the house, or when you're done measuring the refrigerator, you unplug this and you plug it into your, say, washing machine.
Right. So the next thing that you might want to think about is a whole house electrical meter. And there's a couple of different devices out on the market now as well. So this, for example, will clip onto your power meter outside, and there's a little optical reader that will sense how fast that dial is spinning.
So it actually watches that dial spin, and then what, it sends the information to this monitor here?
Exactly. And this monitor goes inside the house. You can carry it around with you, turn things on and off, see what it changes on your power or dollar consumption scales.
This is a wireless version right here. Does this work the same way?
Pretty much the same way, except that this clips onto the wires inside your panel.
Gotcha. So in this case, it's also good information about the whole house, but this unit won't tell you exactly what just the refrigerator is drawing and whether or not the refrigerator is a power hog.
Right, exactly. Now combine these technologies, and we have the next level of whole house energy management and monitoring systems.
What are we looking at here?
This is a breaker box, and we've got current sensors that clip onto each wire.
Gotcha.
So we monitor each circuit individually.
So here's the circuit for the washing machine, and as this washing machine draws load, the sensor reads that and sends the information where?
Over to this power management box. It gathers all of the data from the circuits and sends it to the internet, where you can look at all of that data on your computer.
Let's have a look at that.
All right, we've actually got a live hookup to a real house here that's using 3,122 watts. You can look at that odometer on the left side there.
Well, and there it just changed pretty quickly. So that is actually a real-time reading of what's going on in the house.
That's right. So somebody just came home and turned something on, probably.
And then over here to the right?
That is a list of all the circuits and appliances that are on.
Clothes dryer is on, the mudroom and sink, oil boiler, all the way down to, ends with the home office.
Okay, Kevin, scroll down to the bottom of the page, and you'll see that pie chart.
Oh, yeah.
And we can zero in on any one of those end uses.
So this is the usage over the last 30 days, and there it is. The refrigerator used about 8%, the kids' bedroom and some circuits in the basement 19%, and the home office, that looks like the biggest at almost 28.2%.
That's right, the biggest user here, but I have to tell you, I have this equipment installed in my house, and my power usage jumped one day. I could see that very clearly, and I scrolled through all the pieces of this graph, and I discovered that my refrigerator was using twice the power that it normally does. And I troubleshot that back to a bad defrost coil. Replace that for $20, my power use is back where it needs to be.
So I can click on an individual slice of this pie. I'm going to click on the home office here, and it'll give me detailed information of just the home office.
Exactly.
Oh, well, look at this. So I'm looking at the chart. And here it is at about 5:50 p.m. There's a spike, so the homeowners come home and they turn on their computer screen, their printer and such, and that explains this spike here.
That's right. Now take a look at early in the morning. We've got a 5:51 time marker there, but before that we can be pretty sure nobody's in the office. They're probably still asleep.
It's 4 o'clock in the morning, no one's in the office, yet there's still, looks like about a minimum of 150 watts being used in that office at all times.
Looks like phantom power to me.
So phantom power is this idea that even though you've turned things off, they're still drawing a load.
Exactly.
you turn your computer off, but the printer is still on, or the modem is still on, and that's still using electricity.
Right, and in this case, it's 150 watts. It's like leaving a 150-watt light bulb on all the time.
So this helps us monitor it. How do we actually manage that? What do we do about phantom load?
Well, we've got some more technology, fairly simple to use. Let's take a look at it.
Okay. Power strips, huh?
Right, pretty simple to use. Plug all your peripherals in here.
Mm-hmm.
When you're done using your equipment, you turn it off.
Gotcha.
Everything goes off.
So the only problem is that you've got to crawl behind the desk and turn this off.
That's right. So let's get a little more sophisticated. We've got a timed power strip now. Again, you plug everything into the strip, and you program your timer to turn the home office off at midnight, for example. Everything goes off while you're asleep. You don't even have to think about it.
All right. But there's always something that I don't want to stop drawing that phantom load because I don't want to have to reboot it or reset it every day.
That's right. So you might want to consider a controlled power strip. And these use a controlled outlet to turn these outlets off. So, for example, your computer's plugged in here, and your monitor and printer are plugged in here. When your computer goes off, these outlets are switched off through an internal control.
So no phantom load can come out of those outlets. And
Exactly.
then the red ones here?
Those are always hot. So your fax machine, for example, might get plugged into there.
Oh, that's great. So pretty intelligent. All right, so lots of good information on how to monitor and, most importantly, how to manage our electrical load. Paul, thank you very much.
Thank you.
This is great.